If you look at a topographic map of the Netherlands, 26% of the country sits completely below sea level. The ocean is literally taller than the cities. This creates geographical realities that break your brain. A massive cargo ship legally has right-of-way while sailing completely above a busy highway. Living in a basin next to the North Sea is a precarious arrangement. On January 31st, 1953, a massive storm funneled directly into the Dutch coast, and the existing earthen defenses failed. In a single night, 150,000 hectares of land vanished underwater. The ocean poured in while villages were asleep, leaving 1,836 people dead by morning. 17 days later, the Dutch government issued an absolute mandate: never again. They initiated a 90-year chain reaction of engineering, deciding to rebuild their entire national geography from the sea floor up. The first plan relied on sheer mass. To limit their exposure to the open ocean, engineers decided to shorten the violent coastline by 700 kilometers, sealing off massive sea inlets with solid, impenetrable dams. Beyond blocking the water, they actively took the land back. Fleets of dredgers vacuumed the ocean floor to build ring dikes, trapping patches of the sea. Then they ran pumps continuously to drain these new lakes, pulling entire provinces straight out of the mud. But brute-forcing nature creates an immediate blowback. When you drain that much water, the newly exposed clay soil compacts. The land they had just engineered began to physically sink, creating a brand new flood risk. At the coastline, sealing the sea inlets with solid concrete cut off the natural tides. This choked the oxygen supply and rapidly destroyed every living marine ecosystem that was trapped inside the barriers. Blocking the ocean created a decaying environment on the inside and a sinking surface on the outside. The engineers realized a static concrete box would not work. They were forced to scrap their solid dams and design something entirely new. This diagram illustrates their pivot to save the marine estuaries. They needed a barrier that stays open to let the natural tide flow in and out, but can slam shut the moment a violent storm surge threatens the land. Executing this meant hanging 62 individual steel gates across 9 kilometers of violent open ocean in Zeeland. Each 42-meter-wide steel gate weighs 480 tons and has to drop smoothly into tight concrete guide slots using its own contained mechanical systems. To hold those gates, they cast 18,000-ton concrete piers on artificial islands, floated them out to sea, and sank them 30 meters down into a racing tide. Using only early GPS technology, they landed these massive blocks onto the seabed with a tolerance of just 20 centimeters. The Zeeland barrier successfully maintained the marine ecosystem while blocking storms. However, this specific design introduced a massive economic hurdle. A permanent steel structure stretching across a waterway would completely choke off a working shipping port. Rotterdam is Europe's busiest port. The city needs absolute protection from the North Sea, but building a traditional dam or permanent gate system here would halt the constant flow of massive cargo ships, crippling the European economy. The answer was the Maesland carrying. Instead of building in the water, engineers excavated 2 massive concrete dry docks on opposite banks of the river. Inside, they built 2 enormous swinging steel truss arms, each one heavier than the Eiffel Tower. Looking at this top-down view of the river channel, you can see how it operates. The steel gates are completely hollow. When an alarm fires, the docks flood, allowing the arms to float out into the middle of the river. Once they meet, internal valves open. The gates fill with water and sink to the riverbed, sealing the port in exactly 2 hours. Closing the economic lifeline of Europe is an incredibly high-stakes decision. To completely eliminate human hesitation, the entire closure sequence is run by an autonomous computer system called BOS. When the water hits exactly 3 meters above normal levels, the computer alone decides to close the massive gates. Rotterdam proved that engineers could automate a defense against the ocean without sacrificing global trade. But this multi-billion-dollar steel behemoth was highly localized, leaving rural inland communities searching for a different kind of shield. Small inland waterways face serious flood risks during storms, but tiny farming communities simply cannot afford colossal steel megaprojects. They needed a defense system that was highly effective yet drastically cheaper. Their solution was the Ramspol Dam. Resting completely invisibly on the riverbed are 3 flat, heavy-duty bladders. When a flood threatens, pumps force them to inflate with air and water, creating a 10-meter-tall wall of rubber and Kevlar in under an hour. When the storm passes, the bladders deflate and disappear. It proved that modern flood defense didn't require rigid, permanent defiance. It could rely on invisible, flexible adaptation. But even with steel gates and Kevlar bladders, the Dutch engineers recognized a severe long-term flaw. Building higher and stronger walls is a war of attrition. Eventually, the ocean always wins. In the last decade, the Dutch shifted their focus. They stopped trying to block the ocean and started trying to choreograph it. You can see this shift at the Sand Motor project. Rather than manually reinforcing the coastline year after year, engineers dumped 21.5 million cubic meters of sand in one massive calculated pile. Since 2011, the ocean's own waves have naturally distributed that sand along the coast, building up the beaches entirely for free. Inland, they applied this same logic with the Room for the River program. Instead of raising the dikes higher to contain swelling rivers, they bought out farmland and dug 9 kilometers of brand new river channels. When a storm hits, they intentionally flood these zones to give the water a safe place to go. The impact of this is immediate. Dropping a flood peak by just 27 centimeters through these bypasses is enough to save an entire city from the overflow of a major river like the Rhine. By selectively surrendering land and letting nature do the heavy lifting, the engineers finally secured their most resilient defense system yet. This 90-year evolution has resulted in 0 flood deaths since 1953. During the storms of January 2023, every distinct barrier, from the massive steel arms in Rotterdam to the rural rubber dams, was triggered and monitored by a single coordinated national system. The storms funneling into the North Sea haven't stopped, and the ocean is only getting taller. But between that violent water and the sleeping towns, the Dutch have built a dynamic, thinking fortress. Surviving in a geography that shouldn't exist isn't about trying to defeat nature with brute force. It is about learning how to constantly adapt, engineer around your own mistakes, and ultimately live alongside the water.